Hey there, viewers, and welcome to the Daily Space Weather. And welcome to the Smash News Network, least busted name of news. I'm your host, Dan, a.k.a. Smash-A-Mash, coming at you today from the galactic core. We'll talk more about galaxies later in the video. A little brief cosmology debunkage is going to go on. And by the way, thanks to everybody who left comments yesterday and read comments yesterday. It was absolutely hilarious, a hilarious day in our comments section. If you didn't see them, go check on them. There are some facts that get exposed. And for all of you hoping for zero sunspot days to prop up your theories that have been thoroughly debunked over the past 2 years, here's another sunspot rising. So enjoy that and the rest of our spectacular imagery. Here's your northwestern limb. And there is a possibility of some major flares coming from that region at any point, really. We have seen an uptick in solar flaring a little bit since yesterday. There's your southwestern limb as we go around the horn of the closest star. And thanks for stargazing with us. Congratulations on realizing that the channel exists. There's your southeastern limb. We've got huge filaments and some well-defined coronal holes as well. Let's take a look at sunspots briefly. This is yesterday plus today. We've got some quite large sunspot groups there in the northern and southern hemispheres. As these groups set down here, they're more likely to flare, especially this area up here, though. I see some umbral growth there as well, so some additional sunspots forming around this group. And also, again, a new sunspot forming right up here, dashing everybody's hopes for having a zero sunspot day. Also, we see sunspots at pretty high latitudes, meaning pretty close to the poles, meaning there's a long way to go to get through solar cycle 25. In other words, we're nowhere near solar maximum. Enjoy that. Enjoy all the rest of the facts portrayed on the channel. Here comes some more about volcanoes. So here's our volcano rundown. Suwanosejima exploded and produced probably some sort of ash plume. 5,000 foot area, flight level 050 from Suwanosejima. Karengatang exploding, flight level 070, 7,000 foot ash plume over Siau Island, part of Indonesia. Semeru exploding, flight level 140 over East Java, Indonesia. Tukono exploding, flight level 070, that is. 7,000 foot ash plume over Halmahera from Tukono. Popocatépetl exploding in central Mexico, flight level 210. It's a 21,000 foot plume of volcanic ash. Please do not pole vault the caldera. Please do visit the links, like our red bubble shop, below the video. Fuego exploding in Guatemala, flight level 150. Sangre exploding in Ecuador, flight level 220. And Sabancaya exploding in Peru, flight level 240. No, I don't think the sun causes volcanoes. We cover it because we cover Earth and space weather. Next, looking at seismicity over the past 90 days. There you have a convenient graph from volcanodiscovery.com. And let's run up the list here. No major quakes over the past 24, although we did have some in the 5 magnitude range, which we will cover, like this 5.0 at the South Sandwich Islands. That came in at 13:08 yesterday, Universal Time, on February 19th. So here's another 5.0. That one was at Indonesia, 15:17 Universal Time. And here's one at the Mid-Atlantic, the Mid-Indian Ridge, rather, at 1607, that was a 5.3. There was also a 5.0 at Japan. The South Pacific had a 5.3, just kind of in the middle of the South Pacific Ocean there. Looks like nowhere near a plate boundary. That's interesting. Was it perhaps volcanic activity? Is there an underwater seamount there? Let us know in the comments what you think. I really have no idea. I'm just briefly reporting on this because our viewers like it. Here's a 5.0 at the Philippines. That one was at 3:09 this morning. Also a 5.1 in Tonga at 4:05 this morning on February 20th. And let's get back to space. So this is where we started out. This is the first imagery that we showed on today's video. This is 171 plus 131 angstroms. It really shows great imagery of plasma aligning to magnetic fields. So an important thing to understand when it comes to astrophysics and space weather and cosmology is that plasma is not magic. So you can't just say, you can say plasma, 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 plasma. It does not make plasma magic. Dust isn't magic. Plasma is not magic. Deal with the facts. And let's move on. The 10.7 centimeter radial flux is now at 169 solar flux units. There is the 1 year graph to put it in context. The 10.7 centimeter radial flux comes from the upper chromosphere and lower corona, right about where my arrow is pointed. And it is the most proportional data set to sunspot number. So when we see high sunspot numbers, we see high radial flux, as you may be able to see portrayed in this nice 1 year chart from Solon.info. The black line is the radial flux, the red line is the sunspot number. And let's take a look at the Space Weather Enthusiast dashboard. We did see recently a significant increase in the solar magnetic field measured at Lagrangian point 1. That's a 15 nanotesla field there. And we have NOAA forecasting some geomagnetic storm conditions later today as a result of a CME impact that they're forecasting and we're not forecasting. So yesterday, of course, all the controversy occurred as a result of our correct forecasts and NASA and NOAA's incorrect forecasts. Now, they've changed this at least twice since yesterday's video. And since then, it's become looking more and more like our forecast. So now you can see it's not really expected to hit Earth at all, except maybe for a tiny little portion of it there. So they've greatly revised down their forecast for the impact of the February 17th coronal mass ejection. Now, we cited that almost all of that is on the opposite side of the sun, so it's still not really modeled correctly there. But hey, what can you do? It's at least it's closer than it was. And of course, we were laughing and laughing and laughing at all of the doomsayers who were like, it's going to be a KP8. We're going to have the auroras down in Cuba like the Carrington event. Oh my God, I'm so spooked. Jump in your bunker right away, folks. Jump in your bunker that you purchased from us and filled with prepping supplies that you purchased from our Amazon store and so on. Sorry, you're probably not going to be able to see the aurora in Pennsylvania as a result of that. So that's your Space Weather Enthusiast dashboard breakdown. KP index currently at 2.67. So a little bit of an uptick there in global geomagnetism, but still geomagnetically calm conditions. And let's take a look at the last 4 hours of Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework. So that's depicting magnetohydrodynamic pressure. Again, things pretty chill here. Our BZ is in the positive territory, so while we have a strong field, we don't really have a lot of induced current because we have a positive BZ. That's the vertical component of the magnetic field measured at Lagrange 1. We will show you that momentarily. First, Earth's magnetic moment from the ground for the past 4 hours. That depicts magnetic flux density in nanotesla. And again, we are expecting to perhaps see like a KP4 event. I don't think we'll get to even KP5 if we even see any ejecta from the coronal mass ejection impact, because there is a coronal hole high-speed stream on the way as well, and those tend to interact with each other, sometimes canceling out CME impacts. So here's the current situation. We have recently seen an increase in the plasma temperature here. That's a pretty good signal there. And also a small uptick in the solar wind speed and density. So anyway, current conditions are pretty unremarkable here, frankly. It's about just under 9 protons per cubic centimeter for the solar wind density. Solar wind speed here at about 430 kilometers per second. And expect to see a coronal hole high-speed stream impact as well. There is one of those on the way. It could be here, well, shortly, frankly. So don't jump to conclusions when you see some changes happening today in the solar wind density. It could be coronal hole high-speed stream, not coronal mass ejection impact. We'll have to analyze that as it happens later in the day. So here are your GOES magnetometers, and pretty smooth readings there from the GOES 16 and GOES 18 magnetometers from their geosynchronous orbits. Again, calm conditions here around Earth. Let's take a look at the polarity of the heliospheric current sheet, and we are in the process of snapping into a South Pole current sheet. So that may be what we're seeing in those sudden changes in the solar wind parameters as we move from the North Pole current sheet depicted in green to the South Pole current sheet depicted in red. We're basically right at the sector boundary crossing here. Keep in mind that data is 2 hours old. We are probably already well into the South Pole current sheet. Let's take a look at the line of sight field plot. Since the sun's B field is kind of just moving into the western portion of the sun here, you can see that B field depicted in the blue. The B field is the field that goes through the magnet, this magnet being the sun. And you can see the south solar magnetic pole rotating in. Let's take a look at coronal holes next. So we've got North Pole coronal holes rotating out, South Pole oriented coronal holes rotating in. They should get more defined in the coming days. Let's see what we've got from SDO. Let's bring that to the latest frame there. There's the latest frame. So all the way at the North Pole, man, there's a long way to go too. Check it out. We've got North Pole polarity up here, South Pole polarity down here. Yeah, there's a long way to go for the solar polar field reversal process to even get halfway through, indicating that we're nowhere near solar maximum. So here you've got a North Pole coronal hole. Here you've got a South Pole coronal hole, and this is a very well-defined transequatorial one that should provide some significant coronal hole high-speed winds. Whether or not it'll be a strong geomagnetic storm or anything like that is yet to be discovered. But yeah, so that's the situation there. We are expecting a coronal hole high-speed stream within the next about 24 to 36 hours from this transequatorial North Pole-oriented coronal hole, and let's move to sunspots. Keep in mind, folks, coronal holes are solar radio jets, and they're very important not just for solar polar field reversal processes, they're also important for the solar proton output, the solar wind. A large portion of that comes out of coronal holes. So here we are on sunspots. And we'll have sunspot 3231 will be named right up here in the northwestern limb. Let's take a look at the SDO continuum for the past 24 hours. Again, a little bit of growth around this area here. So we may see some new sunspots named there. As we do see a bit of an uptick around this area. That significantly increases the probability that we'll see major flares from the northwestern limb. That's my best guess. If we're going to see large flares today, and it's significantly possible here, folks, I would expect to see them from the northwest. Although this sunspot that just rose is also magnetically complex. And look at the high latitudes. Not even getting anywhere near the equator there. We've been seeing a big diversity of high and low latitude sunspots all throughout this cycle. Probably a feature of the Terminator event, which we are attempting to get Scott McIntosh onto the channel to talk about. Somebody who can actually forecast solar activity, unlike certain folks who have a lot of followers on YouTube. A lot of cultists on YouTube. Next, looking at energetic particles and solar flares. There's your GOES proton flux. It's flatlined here. No relativistic particles showing up, despite a little uptick in solar flaring there. Only C-class events over the past 24 hours, though, as we ramp down from this X-flare that happened back on the 17th. So there's back to the 3-day view, and let's take a look at some solar flare viewing wavelengths here. Now, this is part of the extreme ultraviolet spectrum. This is 94 angstroms ionized iron, one of the many species of ionized iron covered by SDO. And indeed, it looks like the major flaring was around the western limb, some down here as well. So we could see some significant solar flares there. Looks like some activity in the northeast, too. So here's 131 angstroms, the other wavelength specifically formulated to show solar flares. Remember, folks, solar flares are X-rays, which are photons. And coronal mass ejections are protons, like gas, the difference between gas and light. You understand the difference between gas and light, right? Is anybody trying to gaslight you on the internet? Well, let's hope not. Hopefully they're not making a fool of themselves trying to do it. Remember, folks, if somebody attempts to gaslight and fails, we call it shart lighting. So let's take a moment to take a look at the sky overhead here, Lehigh Valley, Pennsylvania. This is what's going on over the Smash News Network, Lee's Busted Neighbor News. Let me make sure I have the latest image. The sun peeking there over the horizon there, chasing Saturn and Mercury across the ecliptic. If you're up before dawn, you may see Mercury if you've got low light pollution and a low horizon. Next, we'll do the solar system forecast, and happy new moon to all of you reverse werewolves out there. Here's your 1-week forecast for heavenly bodies. Here's where things will be in a week. we will be moving from first to second quarter. Now, if you enjoy the content and you'd like to see it continue to exist and remain publicly visible for all to view, consider becoming a member at smashomash.com/smashteam. You can find all kinds of links there. You can also donate via PayPal. We are also on all kinds of social media. So hit us up there if you're unable to or unwilling to open your cobweb-encrusted wallet and send us a few bucks per month to produce the content. Just click our links. You can find all kinds of interesting stuff that is not depicted in these videos. Exclusive content on most sites. Also links to the merch shop, the forum, and so on. The best value is the gold annual paid-up subscription. Thanks to our gold and silver Smash Team members, there's also a bronze membership there. We do send out email alerts when we list videos. If you click the Hemp Lucid link, you will find our Hemp Lucid shop. You can enter the promo code SMASHOMASH10 if you just head to hemplucid.com and enter the promo code SMASHOMASH10 on checkout. You'll receive discounts. Also, if you shop via our link, you'll receive discounts and perhaps other special offers specific to our Hemp Lucid affiliate/sponsorship. So thanks to Hemp Lucid, thanks to everybody who's picked up products. You may also find a link to our Redbubble shop below the video. If you click that link, you'll find the products in order of best selling. Some of them are for fun, some of them are for serious. They may or may not reflect the apolitical views of the Smash News Network, least busted name in news. And today's featured product is a dig specifically on Ben Davidson, Cosmology Hack Fraud. It's the galactic current sheet. And we're going to briefly debunk Ben's idiotic galactic current sheet concept, which is recycled nonsense from Electric Universe leader Wal Thornhill. Wal Thornhill's galactic superwave nonsensical idea is basically just the same thing as Ben's idiotic galactic current sheet. So if you'd like to celebrate the apocalypse in style and tell all your bunker mates what's caused civilization to end, pick up some galactic current sheet merch. I guess it'll make you much less likely to be eaten by your bunker mates, because you'll be so smart to tell them that it was the galaxy that caused the sun to explode, allegedly, right? Let's talk about why the galactic current sheet is nonsense. So, first of all, this is what happens at the galactic core. All of those bright little objects there orbiting, those are all massive, really hot stars. And each one of those stars has its own radio jets, which means the material coming out of those stars is coming out in all kinds of different irregular fashions. Okay? The galactic core, Sagittarius A star, believed to be a supermassive black hole, is represented by this blue dot right here. Why? Because that massive radio source is being orbited by all of these massive stars, each which has their own output, and Sagittarius A star likely has its own radio jet output, and the total output of all of that is based on the net output of all of those stars and the galactic core, which means there's a sphere around the galactic core of extremely strong radiation. So that's important to understand, because if there was a thing like a galactic current sheet that spread concentrically out of the galaxy from the galactic core, wouldn't we see concentric bright rings on all spiral galaxies? So let me just scroll down here. Since I put up a list, I just searched for spiral galaxies on DuckDuckGo.com. And if you notice, not how many of those galaxies have concentric rings? Do you see one single galaxy with concentric rings there? Most of these are actually images and not artists' renditions. Do you see a single galaxy that has a single concentric ring, suggesting a galactic superwave or a galactic current sheet similar to the heliospheric current sheet that activates stars or something as it proceeds outward from the galactic core? Do you see any concentric rings? No. I can't imagine why. Actually, I can imagine why. The reason is because there's no such thing as a galactic current sheet. Maybe if you're maybe 1,000 light years from the galactic core, but not 26,000 light years from the galactic core, there's just nothing like that. It's not a thing. We would see it in all the other galaxies. And how many galaxies do we see that in? Exactly 0. Not 1, not 12, not 1,000, 0. Exactly 0. So if that's not enough for you, I mean, we can debunk other points of this in the future, but it's just not a thing. The galactic core interacts with the rest of the galaxy via its jets if they're aimed at the galactic disk, or via the spiral arms. The galaxy is nothing like the heliosphere. The solar system and the galaxy are not similar, really, in any way. The galaxy is really big, and the solar system is really small on a galactic scale. Now let's talk about yesterday's hilarious predictions. Here's NOAA's forecast. So there you go. There's that's NASA's forecast, rather. There's the Enlil spiral from the Integrated Space Weather Analysis Center, and this hasn't been revised. So this is what we showed on yesterday's thumbnail, because the other Enlil spiral, the NOAA Enlil spiral, was revised twice yesterday after we put out yesterday's video. So here's NASA's Enlil spiral, and of course you got to understand, folks, NASA does have some reason to actually over forecast a coronal mass ejection. They have people that have to get into a radiation shielded room. They're called astronauts. They could receive a fatal dose of radiation if they are especially relativistic particles, but a CME could provide them with a fatal dose of radiation. So keep in mind, they do need to over forecast, but they have this wrong. It's probably off by something like 140 degrees. It's way off. And let's continue looking at some coronagraphs. So here's some current imagery. This is yesterday plus today. And we did see another, this is yesterday so far. And we did see another significant CME here coming out of the southwestern limb. There you can see that propagating. And we're going to do a little analysis of this here. Here is today's imagery from George Mason University. That's 36 additional frames. And let's break this down. So we're going to look at stereo A, which is only about 10 degrees off of the Earth now. So we've paused this here at 2209 for stereo A and 2206 for the Soho-Lasco C3, because we'd like to get a little bit more accurate trajectory on that. So do we see any ejecta headed down the Earth line? There may be a tiny bit. There could be a tiny, barely detectable Earth-directed component there associated with that CME, but if so, it's very diffuse, and again, it'll be barely detectable if it arrives at Earth. So let's just let those play through here once. Bring this one back. We've got 90 frames there. Please pay attention to the time and date stamps in the lower left. They are not synchronized. Stereo A and Soho-Lasco C3 are completely different spacecraft. So again, there may be a small earthly directed component there from that mostly southwesterly directed CME. If so, it will be minor. So here is some more imagery of that. This is the past 24 hours, another spectacular light show there. And this other CME happening kind of at the same time or at a similar time is sort of on the opposite side of the sun. It's not perhaps the exact opposite side of the sun, as we did see some flaring on this side. In fact, both of those CMEs might be sort of on the opposite side of the sun. It's pretty hard to tell with stereo A being so close to Earth at the moment. So there is our slightly more zoomed in view, and you may be able to see some. Okay, we do see a filament ejecting right here. So you can see the 304 angstroms. We do see a filament eject there. So yeah, that could have a minor earthly directed component, but I sort of doubt it. And if that were to strike, we would expect to see that arrive on like midday the 22nd would be a good estimate for that. Midday, maybe late day on the 22nd. It's sort of an average speed coronal mass ejection there. Probably just another stellar light show. Nothing to be worried about in any way. Next, we'll look at filaments, and we've got massive number of filaments here on the earthly facing portion of the solar disk. Massive number of filaments and massive filaments. This one looks like it's getting a little unstable here, so that one could eject at any moment. We've got dozens of filaments on the earth facing portion of the solar disk. Don't be surprised to see additional CMEs happen here in the coming days. And you can actually see that ejection that we just covered. It came from that filament right there. You can actually see it leaving from the ground-based Cerro Tololo, Chile observatory. So that's fantastic. We've also been naming filaments after living people. Like these two up here this one here certainly should get a name since it's not looking too unstable, but lots of filaments there. So, I mean, over a dozen filaments on the Earth-facing portion of the solar disk. And if you'd like to name filaments after living humans, here's how you do it. You join us over on Twitter. Pretty simple. We're all over the internet, and we're inviting you to name that filament. Filaments are a super important portion of space weather, just like facts are a super important portion of space weather, and we stick to those. We always tell the truth, and then we never slip no lies in. That's a quote from Run DMC, by the way, if you're wondering. Huge fan of Run DMC, of Hollis, Queens, dating all the way back into the 1980s. So anyway, there's your filament view. You're invited to name that filament and join us on Twitter for all kinds of other stuff as well. Thanks for leaving comments, Mike Bordages and Nebula Noob. No, Nebula Noob, it's not a rerun. This is currently being streamed live. So again, join us on Twitter, all of you viewers out there. If you don't have a Twitter account, create one. Create an account on Twitter. It's sort of where it's at as far as social media, as Meta goes right into the garbage. And by the way, there's a link to our free Hemp Lucid Mushroom Gummies giveaway. Right there, our pinned tweet. If you click that, you will have access to free mushroom gummies while supplies last. So maybe check that out if you'd like to try out mushroom gummies for focus, sleep, stress, etc., including immune response. Check it out. People have been enamored by the products. And let's show some more imagery here. We're going to go back around the horn again since we've got so many filaments. Check out the filaments. So 2 well-defined coronal holes here visible and lots of filaments all around the solar rim and around the Earth-facing portion of the solar disk. Look at the size and density of these filaments. Likelihood of additional coronal mass ejections today, nearly 100%. Let's briefly go around the horn here. There's your northern hemisphere. Spectacular prominence there up in the northeast. The most active region on the sun likely there in the northwest. And here's a great view of the southeast. That South Pole-oriented coronal hole down there. Great view of that. Also huge filaments. Filaments, filaments, filaments. All right, so here's the past couple. Those are all 24-hour videos, by the way. This is the last about 2.5 hours from the GOES 16 SUVI. And especially keep an eye on this filament up here, because this one here, it looks like it's already getting unstable. I think it's in the process of ejecting or perhaps splashing back down, or maybe even just repositioning itself. Sometimes that happens. Sometimes the filament actually moves and stays suspended. Also a huge magnetic loop here. We can see plasma bridging there across the solar equator. That's another spot where you can see some significant events happening, as that huge filament there, thousands and thousands of miles in length, could collapse and be associated with a large solar flare. That brings us to our bonus features section. Let's move to satellite charging hazards. At the moment, just some minor surface charging hazards here in the Central Pacific. Those are caused by low-energy electrons building up on the outside of spacecraft. Let's take a look at the GOES electron flux. There's the past 3 days. If we do see a CME impact, you can expect to see this cratered. Let's see what the NOAA forecast is for the electron flux. So NOAA expecting a little dip there. I would say this is a coronal hole high-speed stream. I mean, if we do see a significant CME impact, which I doubt, this could drop down a little bit further, but hey, no major arguments there with that. So here's the 1-year graph to put the relativistic electrons in context. These are measured at the F layer of the ionosphere by the GOES 16 and GOES 18. So we'll show the vibrational frequency of that layer of the atmosphere, the F layer. Feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation, thermospheric temperatures, and molecular concentrations. Here's the vibrational frequency of the F layer of the ionosphere, the bridge between Earth and space. We are seeing continued major low-frequency anomalies here, northeast of the South Atlantic anomaly, which is over the South American continent, and so on. All right, let's bring up the latest image here. We don't want the video to be too long. There is your anomalygram. That's anomaly in megahertz from the 30-day median. It's doing a great job of showing the South Atlantic anomaly, which is right here. And that's Earth's weak spot. the most likely place to see ion fountaining happening there, as you see those huge variations in anomaly happening all around that one area. That's the South Atlantic anomaly, now back in place where it was over the South American continent. We showed it move thousands of miles a few weeks ago. It was pretty confounding. And if you've got ideas as to how Earth's magnetic field is generated, please let us know in the comments. Here's the latest image at 12:30 Universal Time ionogram and 12:30 Universal Time anomalygram. We'll also show the total electron content, which is a little koofed right now. We hope it's not because somebody set off a nuclear weapon, because that could create issues. If somebody sets off a nuke in space, it would affect the total electron content. This depicts the free electrons between your GPS satellite and your handset. So here is our total electron content view, and it's very limited data there. It's only the North American. And unfortunately, the regular view that we normally show, the global view, has not been functioning here. So that's unfortunate. It's not going to show us the most likely places for GPS errors, so let's move on to the latest intensitygram and latest colorized magnetogram. So here's this new sunspot, 3231, is it? It's already beta gamma class. Could even be beta gamma delta class. We'll have to wait a few hours for that to rise, as that might have more umbre than are currently visible. But there's the current situation. Again, some growth around this area. So the most likely place to see major flares is around here. Again, we do have that equatorial plasma bridge and so on. So let's continue on here to our meteorology segment. So we like to shove a meteorology video into our daily space weather content. So let's do that. We're starting things out with the coldest place in the world. Yeah, the coldest place in the world. It's currently located in Arctic Canada. 51.2 degrees Fahrenheit, below zero. Yeah, that's pretty cold. It's colder than Siberia and colder than Antarctica in Arctic Canada at the moment. It is wintertime up there, by the way. And Western Australia, kind of hot, nearly 100 degrees Fahrenheit over there on the west coast of Australia. So let's move to meteorology here, and here are your surface winds of the eastern side of the planet. Jet streams of the east. The best global weather pattern to use to predict global weather, the best data set to predict global weather patterns there is the jet stream, the 250 hectopascal winds. Strong jet there over the northern Pacific. Less coherent jets in the southern hemisphere. Here are the jets of the western world. Huge jet stream bends there off the coast of San Diego, actually. Jet surface winds of the western world looking like this. Some strong winds there in Texas and in the central Rockies. Probably a lot of hot air blowing out of the Rockies. Hot air and Colorado, they go together, as there are a lot of people spouting nonsense in the state of Colorado. A lot of people moving there, too, because they've believed so much nonsense. Yeah. Let us know how deep your bunker is in the comments. So there are the surface winds of the central world, and these are the jets. Let us know the depth of your bunker, folks. Is it just the basement? Is it like 2 stories deep? Is it 10 stories deep? Are you scared and spooked of the sun, the provider of all light and life on the planet? Now we're looking at clouds and fog over Croissant Earth. Yeah, Croissant Earth. NASA wants to tell you that Earth is shaped like a sphere, but people that view our channel are well aware that Earth is really shaped like a croissant. To quote Jerry Seinfeld, it's funny because it's real. Anyway, those are clouds and fog over the Americas. And let's blast through some more weather data and close this thing out. There is your weather.gov map, and we've got some heavy snows there forecasted, especially for the northern Rockies. So that hot air from Colorado primarily goes from west to east because of the jet stream. It's not going to warm up Wyoming. Let's scroll down and show the key. There is the key. And the key to forecasting your weather, folks, is understanding physics. Seems pretty easy. It's not easy for a lot of YouTube channels, though, who don't understand jack. They try to cover space weather and Earth weather, and they don't know anything about either one. If your county's lit, click your county on weather.gov. Here are some forecasts. This is a 72-hour GFS temperature anomaly forecast in degrees Celsius. And some very warm temperatures here coming especially to the southeastern U.S. and some very cold temperatures creeping in from central Canada, starting in Montana and the Dakotas and making it all the way down into Oklahoma, actually. Very cold temperatures there. Temperature anomaly forecast based on a GFS 72-hour model. Here is your 72-hour GFS pressure and precipitation forecast. Yeah, heavy snows there coming in the next 3 days. All that hot air is not going to prevent Colorado from being blanketed once again. Huge ice storm coming. Look at this ice storm. Dag! An ice storm headed all the way from Iowa across Pennsylvania. Huge ice storm there in the forecast. Yowzers. That is going to be some serious ice accumulation if that continues to play out that same way. Next, your positive accumulated snow depth change forecast in inches. This is your 72-hour GFS positive accumulated snow depth change forecast. And yeah, some heavy snows there coming to especially Wyoming and South Dakota, also southern Minnesota, expecting some major snows there, pushing the 2-foot margin. Also some heavy snows coming to California. Shout out to Smash Staff's mom. She's going to get buried once again. Also Oregon expecting some heavy snows. Again, that's your 72-hour GFS positive accumulated snow depth change in inches. And let's just show the Euro model for that same time period on windy.com. So there's the Euro model and there's the GFS model. Once again, Euro model, GFS model. Euro model now altered to show a little bit more snow in Mexico. Yesterday it showed a little less. Now it shows a little more. It looks like the GFS might be a little more correct there. Anyway, once again, there's a Euro model and there's the GFS model. That was new snow, by the way. New snow is what we're showing there on windy.com. So here's our lightning mapper, and nothing doing around North America there for lightning. Let's check a real-time lightning map from lightningmaps.org. When I hear thunder, I bring it up regularly. I think I even have it in my favorites. Lightningmaps.org. Convince the natives that you're Zeus or something. Now, if you enjoy the content and you are unable or unwilling to open your cobweb-encrusted wallet, just click our links. That helps us out as well. So smashomash.com is our homepage, and welcome to the Neo Renaissance. Let us know in the comments what your favorite social media is, as we're all over the internet at Smashomash. Also, check out our record label, Golden Cat Productions. You can find it on Spotify, Amazon Music, YouTube Music, etc., iTunes. Golden Cat Productions is our original music label. Press like, subscribe, share, etc. Tell your friends and foes about the channel, as we don't believe YouTube recommends us, as we should be a little bit more than 2.71 thousand subscribers now, having put up the most detailed space weather imagery and comprehensive imagery of the sun you'll find anywhere in the known world for pushing 6 years. Thanks to our friends and foes who view the videos. Did you know that our thumbnails contain more information than entire YouTube channels? It's true, folks. To quote Kurt Angle, it's true. We'll close things out with the U.S. Doppler radar map. And there you have that. We'll stick with the lower 48 for the remainder. There is vertical motion of water droplets and ice crystals in the air column. The U.S. ground-based Doppler radar systems. Here is the satellite-based 3.9 nanometer infrared radiation map showing clouds and fog over a half-dark country. And there is the water vapor map. You can see some cold air already rushing down there into western Montana especially, and some moisture making its way into the Pacific Northwest. Here's your recap to close things out. U.S. Doppler radar. Those are ground-based radar systems that measure vertical motion of water droplets in the air column. Shortwave radiation shows infrared radiation, which depicts clouds and fog at 3.9 nanometers. And there is your water vapor satellite. That shows all the water vapor. And check it out. There's some evaporation happening here in Colorado. Why? Because of hot air. All right, so thanks for tuning in, folks. Congratulations once again on realizing the channel exists. We'll see you soon at the Smash News Network, least busted name in news. And may that solar wind be at your back.